For over 2 decades, one aircraft ruled the skies with unmatched speed and elegance: the Concorde. With its sleek silhouette, delta wings, and nose that seemed to pierce through the clouds, Concorde wasn't just a plane. It was a symbol of technological audacity. Capable of cruising at over Mach 2, twice the speed of sound, it could take you from New York to London in just 3 hours. It was the pinnacle of civilian aviation, and for those lucky enough to fly it, the experience bordered on surreal. At 60,000 feet, passengers could see the curvature of the Earth while sipping champagne at supersonic speed. But Concorde was also a paradox. Futuristic, yet flawed. Only 14 were ever built. Each carried around 100 passengers, but required an enormous amount of fuel. Maintenance costs were astronomical, and it wasn't profitable for most airlines. Despite its performance, Concorde was more of a luxury icon than a commercial revolution. Eventually, it was retired in 2003, marking the end of an era. But Concorde wasn't the only supersonic airliner. During the Cold War, Soviet engineers, eager to match Western advancements, developed their own high-speed passenger jet. The Tupolev Tu-144, often nicknamed Konkordsky for its uncanny resemblance to the Concorde, the Tu-144 had a dramatic and controversial history. Its first public appearance ended in disaster. At the 1973 Paris Air Show, the Tu-144 crashed in front of thousands of spectators, killing all crew on board. The event raised questions about its safety and design. Though it did eventually enter limited service, the Tu-144 was plagued by mechanical issues, inefficiency, and low passenger confidence. Its lifespan was even shorter than Concorde's. For over 2 decades since, no one dared take on the challenge of developing a new commercial supersonic jet. Until now. Enter NASA and its bold vision for the future of flight, the High-Speed Civil Transport, or HSCT. Designed to replace Concorde with a more efficient, larger, and economically viable airliner, the HSCT could be the aircraft that finally brings supersonic travel to the masses. Twice the size of Concorde and capable of carrying up to 300 passengers, the HSCT is a sleek, futuristic marvel. To reach speeds beyond Mach 2.4, its design resembles that of a rifle bullet, long, slender, with a sharply pointed nose and tapered tail. This shape is necessary to reduce shockwave drag at supersonic speeds, but such a design introduces an unusual problem: visibility. A pointed nose severely limits what the pilot can see during takeoff and landing. Concorde tackled this with a droop nose, a mechanical system that could lower the nose cone to improve pilot vision. But this innovation came at a steep cost. The droop mechanism weighed over 10,000 pounds and required intensive maintenance. NASA engineers knew they had to do better. Their radical solution? Remove the front-facing windows altogether. That's right, a cockpit with no windows. Instead of relying on the human eye, the HSCT would use a fail-safe system of infrared cameras, radar imaging, and high-definition video feeds to simulate the outside world. These systems would display a virtual runway in real time, allowing pilots to land safely without ever seeing outside the aircraft. It's a bold concept, but would it work? To test this theory, a team of engineers converted the cargo hold of a Boeing 737 into a completely blind cockpit. No windows, no direct line of sight, just cameras and screens. 2 test pilots took control of the aircraft, relying solely on data and video feeds to attempt a landing. Against all odds, the test was a resounding success. The pilots not only landed safely, but the system provided them with better visibility than a traditional cockpit could, especially in poor weather or low visibility conditions. A new chapter in cockpit design was born. But NASA wasn't done. With the hardware validated, The next step was to train pilots for the HSCT long before it even existed. To do that, NASA turned to the most sophisticated simulator on Earth, the Vertical Motion Simulator, VMS, at NASA Langley. At over 120 feet tall, this $70 million facility can mimic the motion of virtually any aircraft in existence, or even those that haven't been built yet. Inside the VMS, test pilots experienced the HSCT's flight profile, control behavior, and virtual cockpit interface. Every jolt, every vibration, every airspeed change, all faithfully recreated. The simulator was so powerful and lifelike that its roaring hydraulics were used to create the sound of the T-Rex in the original Jurassic Park movie. With the help of the VMS, engineers could adjust the flight dynamics of the HSCT in real time. They could simulate catastrophic failures, test emergency procedures, and fine-tune the way the aircraft would handle in all weather conditions before the first bolt was even drilled. But even if the HSCT becomes reality, there's still one fundamental challenge: engine technology. Current jet engines, even the most advanced, are limited to about Mach 2.5. Beyond that, they overheat, lose efficiency, and eventually stop working, because they rely on oxygen in the atmosphere to burn fuel. Above certain altitudes, there simply isn't enough oxygen. That's where the story will shift next. In the upcoming segment, we'll go beyond traditional engines. You'll discover how NASA, Boeing, and DARPA are developing the next generation of propulsion, from air-breathing rocket engines like Hyper-X to laser-powered saucers, and eventually to aircraft that can launch into orbit and fly across the globe in minutes. The dream of flying from Los Angeles to Tokyo in under an hour is no longer fiction. It's an engineering challenge, and one we may solve in our lifetime. Stay tuned to Infinity Beyond, where supersonic dreams take flight and imagination fuels the journey.